Hey everybody, welcome to another CS 302 assignment, and for this one, I guess this is called word classification. And of course, there's like this paragraph there. It's just a little story, or just a funny story about, just a make-believe story about this problem. This is also another ACM coding, a competitive coding type problem. So this assignment basically, it's going to be about the following case. So we have a list of sort of buzzwords or keywords. And there will be a set of, I guess you can call it maybe an abstract for a research paper, or like a paragraph that describes a research paper. And there's going to be a set of keywords that classify the type of paper it's going to be. So when you have to have your program scan through the abstract and you pick out all those keywords, you want to determine based on the keywords what type of paper is it about. Is it about physics? Is it computer science? Is it graph theory? Computational geometry, and so forth. So you want to classify what type of paper, what type of category this paper's abstract would be based on these buzzwords. And what you're going to do is you're going to want to use an unordered map to allow you to not have to do a lot of linear searching. So you want to store words into a map and then very quickly be able to track which words are used in the current abstract, and then very quickly determine, based on those words, what type of classification of this abstract, this paper, it would be. So that's the idea. So let's go ahead and now just go over the input, and I'll try to give you some kind of hints as to how you want to use an unordered map to complete this assignment. Okay, so I do have the input and output given to you here in the PDF, but I'd rather, of course, talk about it as well here in the video. So each input case contains first a number at the very top, which tells you how many test cases you will work on in this file. So this first file, you have one test case. The second file, you also have just one test case. The third one, you have 3 test cases. And of course, I will highlight those as well in this video. Let's first go back to the first file. So after you have your test case amount, now the next number, this number 2, is going to tell you how many categories you're going to have in this current test case. So here we have 2, which means you have 2 categories. So essentially, here's our 2 categories. There's graph, then there's geometrical. So when looking at the category, the first thing you have is the category name. This number 4 tells you how many words are going to be in the category. So 4, so then you can see here there's going to be 4 lines or 4 words in this category. And then 3 means that you must have exactly 3 words, 3 distinct words in this text in order for this text to be classified as graph. And it can't be at least 3, it has to be exactly 3. If it's more than 3, then it's not a graph. It's kind of weird, but this is one of those ACM coding problems, so they have to make it a little bit strange. So you read the word graph, you read 4 and 3, so that means you have to read 4 words, like so, and you store 3 into a variable somewhere, or into an array, or vector, whatever you want to call it. Then your next category, since you have 2 categories, next category you have the word geometrical. That's going to be a category name. And then you have 4 and then 2. So 4 means there's going to be 4 words in this category. And this 2 means that there has to be 2 words has to appear, 2 distinct words have to appear in this abstract right here. So essentially, you have to somehow find a way to store this into in this case, into an unordered map. Now, you want to avoid linear searching. Now, again, you have to linearly traverse the input to populate your structures. That part is okay. That's not a search. That's just linearly traversing this list of words. And also, when you have to iterate and read through all the words in this text, this will be kind of a linear traversal, but again, you have to linear traverse this abstract to extract each word one by one. But the thing is, when you're trying to determine if that's the word neither, if the word neither, is it in the graph or geometrical category? In order to find that, you don't want to have to linearly search through this list of words to see if neither appears in this graph keywords or in this geometrical keywords. You want to use a map, an ordered map, so in constant time you can just determine if this word belongs in either category. So, I mean, there's a way you can approach this. So, what if we, well, I guess I can't really say more, because if I say more, I'm giving away the answer. But you want to find a way to take a word in this file, look at that word, and in constant time determine if this word is in the graph or geometrical category without linear searching these two lists of words, is the idea. So I won't say more, but it's a very easy solution for this. Now, sometimes in this input file, a word can appear more than once. You don't want to process the same word multiple times. You may have to have additional maps, one that maybe maps a word to a Boolean, true or false, that tells you if that word has been seen before already or it hasn't been seen yet. So for example, the word this, you see it once already, right there. If you see this again, you're not going to actually process that word again because you already processed it earlier. So you want to first get the words, and you want to be able to essentially remove duplicates, essentially, and going through each word one by one, try to see which category it belongs into. And if you get exactly 3 words that are graph, output graph. If you get exactly 2 words that are geometrical, output geometrical. So you could get both graph and a geometrical, or let's say, for example, you could have a case where this whole entire text does not actually have enough words to be classified as graph or geometrical. If that's the case, you want to output the string SQF problem. I'm not sure what that means, but that was from an old ACM competitive coding problems, so SQF problem. So now for input 2, same idea. We have one test case. We have 3 categories. So our first category is the word math, followed by 10 words. You must get 5 words of this category. So in this text right here, there must be 5 words in that text in order for it to be classified as a math category. So there's 10 words in total right there. Then you have 3 categories in total. So next category is physics, 11 words, and there must be 4 matches in this abstract. So 4 occurrences of these words must appear. And of course, 11 of these, so you read these in. Then comp sci, there's 7 words, and all 7 of these words have to appear in this text, or 7 sort of distinct, 7 unique instances. So if time appears twice, let's say, then you only count that once. So you might have to use a series of unordered maps. So you may have to have several because you want to have maybe a counter, so mapped. So let's say you want to have a map that maps a string to an integer that tracks how many. So for example, you can have maybe a map that takes the word math and maps it to an integer. So you want to track how many math words have been seen in this text. And you want to have another map that possibly maps a keyword to the category, another map that maps a word to Boolean, true or false, that tells you if that word has been seen yet or not. So that's the idea. So after you read in all of this, you then have to parse this abstract and then just start determining what category it is in. Now, for the output, you want to output, let's say for example, this text has enough words to be in the math category and physics and comp sci. You want to output math, physics, and comp sci in the same order it appears in this list of categories. And the reason why is because for code grade, it makes it easier to automate this. So if you output let's say if all 3 categories, math, physics, and comp sci, this text can be classified to all three, you don't want to output comp sci, then physics, and then math. Although it's still correct, but it will mark it wrong on code grade. Now, of course, we can go through and maybe give the points back, but to make things easier for everybody, just try to, maybe you can store these three categories, math, physics, and comp sci, in a vector of strings, just to maintain the order. Then, of course, all of your actual searching, whenever you're doing a search, like when you want to see, for example, as you traverse this file, you want to see if, like, the word applications, is that a word that's in comp sci, physics, or math? Well, then you don't want to have to search linearly through the list of these words. You want to, in constant time, be able to determine if this word does map to comp sci, physics, or math. So in constant time. Now for the last input, this one has more test cases. It's just a difficult one to actually parse. So you have 3 test cases. So our first test case, we have 2 categories. So we have math and we have graph. So math, we have 10 words. We must get 5 matches. The next category, graph, has 4 words, 3 matches. And then we have, of course, our input. And we separate the next category by end of line characters. So after we reach an end of line, so every line is ended with end of line character, but when you have a blank end of line like this, that denotes the end of this test case, and now begins the new test case. In this test case, we have only one. You only have one category, geometrical, with 4 words. You must get 2 matches. And then here is the actual text. Again, every line ends with a new line character. And of course, the last line will be a blank line by itself, which denotes the end of this this test case. Sorry. In this new test case, we have 2 categories in this third test case. Comp sci, 7 words, you must get 2 matches. And then physics, 11 words, 4 matches. And of course, here is our text at the very end. So input 3 will be a little bit difficult to actually parse all of these, but luckily on CodeGrade setup, at least how I have it set up right now, each input case is weighed the same. So if you can't get a third test case, it's not going to completely dismantle your grade or completely just destroy your grade. But you know, the third one's a bit of a trick to do. So pretty much just to recap, you may want to have more than one unordered map. And you may want to have, I would just suggest, have for each category, map it to a count. So you count, you tally up how many geometrical words were seen. So if that count at the end equals 2, then okay, then this text can be classified as a geometrical category. And of course, same for the other categories. Maybe one map that maps a word to a Boolean that tells you if that word has been seen in the text or not. Maybe one map that, you know, maps the keyword to the category. So then you can quickly, in constant time, can determine if this word is a keyword or if it's just any other regular word. So that's kind of like, I went over the input and I gave you some ideas in this segment of the video. Let's go ahead and now just go over some test runs of this program. So for this program, you only have to submit one file, just a main.cpp. You can, of course, include unordered map. You also can include vector. You may need a vector at certain points, not for searching, but to store, you know, the category names in their correct order. And also when you want to parse the input file or parse, you know, this portion of the input, like the actual text, maybe you can, you know, store them into a vector of strings if you want. So that's all okay to use that. So in this case, to compile, you would just have to, of course, just have g++ main.cpp. And again, to run this, we're going to once again use a Linux redirection. So we would just do /a.out, and for the first file would be just, again, input01.txt. And essentially, all this really does is that our cin variable is now going to read from this file. So we can treat cin just like an input file stream variable. So it will parse this input file. So cin is like your IF stream variable. So I run this. We had test case 1, and it was SQF problem. So I guess it turns out that this text couldn't be classified as graph or geometrical. So either we didn't have exactly 3 words from this list appear in this text, and we didn't have 2 of these 4 words didn't appear in this text. So remember, if let's say it would have been more than 3, that still wouldn't work. So it's a very weird program that has to be exactly 3 words in this list has to appear. So it's kind of weird, but we'll go with that. And then for input 2, so here we have test case 1, and all 3 of these actually, so we have exactly 5 words in the math category that appear in this text. We actually end up having 4 physics words, and all 7 CS words appeared in this text. And of course, for input 3, it's a bit of a trickier one. So there are 3 test cases in this one, if you recall. So in the first test case, it was SQF problem. So math and graph, there weren't enough words to have this text classify as a math or graph category. Test case 2 had only 1 category, and turns out it was able to classify this text as geometrical. So 2 of these words appeared in this text. And for test case 3, again, was SQF problem. So I guess in this one, same idea. We had 2 categories, and this text wasn't actually able to, we didn't get 2 CS words. We didn't get 4 physics words. So there we are. So you have to do 1 main file, upload that to CodeGrade. It's going to test against these 3 input files. So hope this video does give you an idea of how to start on the assignments. So I guess that's it for right now. Till next time, and happy coding.